And now it's actually time for our last speaker of the day. We've had such a good day. We've been talking about all sorts, everything that's happened already, everything that's happening presently. But in this speaker and in this talk, we're going to be delving right into the further future. And our speaker is very, very young, come all the way from New York on an overnight flight, bless him. This is Samay Lakhani, Future of AI and Connected Brain, which looks at AI beyond ChatGPT and our brains potentially hooking up to the cloud in the future. Standing ovation, please.
And I'm studying basically the intersection of mind and machine through neurotechnology. And so today I'll be talking about AI and the connected brain and how we can apply AI beyond just ChatGPT and large language models. So how will the future look when we connect our brains to machines? So I'm not much older than many of you people, and starting as like a high school student, I was always interested about just movies like Marvel and Inception, and I was just inspired by the kind of tech, the futuristic tech that they had in there. And over the pandemic, I just became obsessed with AI, like thinking and building and creating and just writing code, because everybody had time, so that's what I was doing. And one really interesting thing that I noticed about it is that it's all about like the data you put in and the data you get out. As long as you have some kind of pattern in your data, you can pretty much get whatever you want out of it, as long as you have some way to teach the AI model how to learn those patterns. And so, for example, if you wanted to classify images of dogs, you could just put in a picture of a dog, and then it can classify it and say that this is a dog. And you can apply the same kind of learning paradigm to pretty much anything. And you can apply it to brains too, it turns out. So brains, you can extract a lot of data from them, and we have the exact labels and the thoughts that we're thinking of. And we can apply that learning paradigm to actually learn the exact thoughts that we're thinking of. So the question I want to ask you all today is, what if I could read your mind? So this is a pretty loaded question, and it can get into a lot of ethical conversations about should we read minds, but really quickly before that, I'll go into my journey from curiosity to kind of like expertise and how I learned. I'm not much older than any of you, and I kind of just want to share my journey to explain how maybe if you're interested in something also, how you can get into it. And I've learned pretty much you can learn whatever you want. So starting off, I just was interested in technology, like whatever new devices were coming out, whether it was like the new iPhone or Mac or just tech in general. So I started building out my setup because I loved gaming. So I would, scavenge monitors and put together like triple monitor setups for like Microsoft Flight Simulator or even Minecraft, just to see like how immersive it could get. And over time, my setup developed to more and more. I just like found random computers. And this is the height of the pandemic. I was on like 3 or 4 Zoom calls at once. And I built a gaming PC, and eventually that gaming PC, the GPU, the graphics card that I was using inside of it, became less used for gaming and more for computationally heavy workloads, like coding, training AI models, because GPUs, of course, have multiple functions. And I was just coding and building AI models with these kinds of things. And eventually, I wanted to go deeper into technology. I didn't want to rely on what other people were building. I didn't want to rely on other people's just code and then just start running it. I wanted to build something new. So I wanted to get into the research field and try to contribute something new, because I feel like I had, the skills just learning over the pandemic. So what I did is I sent out over 60 emails, 60 personalized emails to mentors to see who can I learn from and who is better than me, significantly better than me, and just so I could learn how to build new things. And I had only 3 responses, which is not really encouraging, and 2 of those responses were no's. And no, I didn't get a single yes, I got a maybe. But once I got that maybe, I grabbed it with both hands, and I basically, the person who said maybe, I kind of just annoyed them until they kept talking to me. So I just like follow up on the emails until they eventually started teaching me, and I could go to their lab meetings. So I basically clung to that opportunity, and fast forward to today, I'm studying at Columbia University, researching into brain-computer interfaces. So that mentor that I had reached out to in high school, I was doing research in high school, and I had a lot of people, supporting me. And eventually, I got into Columbia University as an actual university student. And today, I'm going to talk about brain-computer interfaces. And basically, I'll get into the basics of how they work and how we can apply them with AI and what kind of impact they can have on your future. So, to begin, there is the basic hardware that we have for recording brain signals, extracting data. This is what's known as an EEG headset or an electroencephalogram headset. Each one of those electrodes on top of your head track different electrical signals that are coming through your brain. It goes through the skull and the skin just to pick up those electrical signals, and it's non-invasive, so it just sits on top of your head just like a cap. And it will not win any beauty contests, as you can tell by this really goofy picture of me. But it is pretty useful, and it's a really easy way to get started just collecting data. And if we can imagine the EEG as like a car radio, this is like the 4K TV of recording brain signals. It tracks the blood oxygen movement around the brain. So whenever your brain is doing like a workout, I guess you could say, like solving a puzzle or a math problem, or just daydreaming, we can track where the blood is going inside of your brain to see which parts of your brain are activated. So we have fMRIs and we have EEGs, which are non-invasive, which means you don't have to drill inside of your head to get signals. And with invasive implants, like Elon Musk's Neuralink or other similar hardware, we can get right inside the brain, right under your skin, right under your bone, to connect directly with the neurons and the synapses inside of your brain. Generally, these are super accurate, but of course, there's that question, am I going to get permanently hurt if I start drilling holes inside of my brain? And that's a little scary for a lot of people, and of course, there's a lot of medical testing it has to go through, but eventually, I think this is going to be what most people are going to end up using, because it's a very portable, very cost-efficient or energy-efficient way of recording brain signals that's really accurate also. And this produces incredibly precise information that's really useful for medical purposes and advanced research. So the question is, how do we involve AI into this? And going back to that paradigm of teaching a model how to decode the signal, you start with these basic signals that go up and down. These are like the electrical signals you get from each one of the electrodes on the EEG headset. And the signals go up and down, but as humans, we can't understand what that signal means. But of course, as humans who are thinking those thoughts, we know on the other side what those signals mean. So if I'm thinking of the word car, as an example, we know that there's waves and signals associated with that word, and we know that we're thinking that word, so we can kind of pair the two together and use pretty complex algorithms. I'll explain in this simple diagram how we can use an AI decoder, not too dissimilar from large language models. So you start, of course, with the electrical signal, a bunch of up and down waves that we can understand. We use some kind of AI decoder, which is like a simplified black box here. And then we can come up with some kind of prediction or output. So this means as long as we can figure out what you're thinking about, we can map it to a command or some kind of meaning from that idea. So here are some really cool practical examples of how it can work, and I think each example gets cooler. This is examples of the cutting edge research that's happening right now, and I would say because of the advancements we've made with models like ChatGPT, we've been able to actually advance the field of neurotechnology, because again, it's just going back to that decoding and learning process. So the first example from Georgia Southern University is basically the idea of controlling drones. We can calculate basically the signals in the motor cortex using just an EEG headset and look at how are the brain signals changing. So about here, This part of your head is the area where the signals are recorded from, and we can tell the drone to move forward, backwards, sideways, up and down based on just thinking about where we want that drone to go, which is pretty crazy, but it gets a little bit better than that. Next is basically speech recognition and processing. In this case, there is an fMRI device used, as I said, like super advanced, basically like the 4K TV of recording signals. You imagine the words that you want to speak, and you don't even have to speak them, you don't have to move a muscle. You think about the words that you want to speak, and then it generates that on the screen. It just types it out. So we have these kinds of brain reading devices, which is cool. But now going back to the idea of inception, here's where it gets a little bit crazy. The other question I have to ask you all is, have you ever wondered what it would be like to live inside someone's memories? Not just record the text that they're thinking about, but like the images that they're imagining inside of their head. So this is a rough sketch from one of the newest papers that's been out so far. So you start with a picture of a goose, or a duck. Yeah, swan. Yeah, biology is not my strong suit. Yeah, so there's an animal, right. So we sit a patient down and they look at a picture of an animal. And it comes up with some kind of brain signal. And we can decode that brain signal, and we can come up with a relative reconstructed image of what that person is thinking of, because we have that data pairing, right? So we can apply this idea to other images. So we have a visual stimulus that the patient looks at, like giraffes, cricket, a person playing baseball, and we can come up with a rough sketch of what that person is thinking of just through the fMRI without, without any images of like the actual original picture, based purely on the brain signals that they're looking at. So you can see like the giraffe in the first picture is facing in the same direction. It's in a similar environment. The images are almost exactly the same, or like in terms of their meaning and significance, they're exactly the same. Of course, the technology is not perfect yet, but it gets even better in this next slide. Not only have they been able to decode images, they've been able to decode video. So this is at a 1/4 speed, so this is actually slowed down. But if you look at the original ground truth video and the reconstructed videos, you can see that, there's a jellyfish swimming around, and you can see there's also like marine life on the right. That's reconstructed from that original piece of data. And we can record this almost in exactly real time. We're literally reading the videos that you were thinking of inside of your head in real time. And this has a lot of practical applications, of course, for the future. I mean, like, this is just mind-blowing because almost all of this new research has been coming out this year. And so one of the first practical applications beyond just having to read your thoughts like Inception is breaking free from traditional input methods. Communicating with your hands and your fingers, which are kind of meaty and kind of slow, could be a thing of the past. You don't have to use a keyboard or a mouse anymore. You could just think where you want to go on the internet or think about where you want to click, and instantaneously, you would go to that place. There's faster information transfer, which means that when I'm explaining words to you, I'm using the muscles that I use to eat and like altering sound waves, which is a really, really inefficient way to communicate. There's like a huge informational bottleneck there. And it just doesn't really make sense that talking is how we evolved to communicate information. I mean, like, yeah, it's just a weird thing that we do. And I think we're just all used to it. So imagine having to like basically just downloading information into your mind. And that might sound a little bit scary, and it goes back to the ethical implications of it, but you and I can communicate at a much faster rate than we were able to before by just communicating these brain signals directly, which I'll get into more. And because of this, we can pretty much unleash the full capability of the human mind. If we have a direct line of communication of the direct meaning of what we're trying to express, we could change a lot about how we communicate with each other. One thing that I'm really excited about is brain-to-brain communication. And while this isn't a reality yet, it is I think, soon going to be possible. I think we're on the brink of kind of changing the world and being able to share our thoughts directly. When I say a specific word, like the word car, I have a different set of images and experiences that come up inside of my head when I'm communicating that word to you. And so do you. You have a different idea and emotion and experience with cars yourself. But if you were able to directly communicate that information with another person, the exact emotions and experiences that you've been through, we could communicate at a closer level than we ever have had before. So imagine two people living on opposite ends of the world, speaking entirely two different languages. If we could connect their brains together, then they could be able to communicate at a level that nobody has been able to communicate at before, because everybody else was just using their mouth muscles and just making noises out of their mouths. And here you can basically connect the exact understanding of those words together. We could break down barriers that have existed for thousands and even millions of years, because those two people speaking entirely different languages could communicate closer than two people speaking the exact same language but using words. So here I am today. I'm studying at Columbia University, and we're working with these robots. These little robots are about 1 foot long, and they have magnetic ends, and they move just like pistons. They expand and they contract, and they all connect together. So they're like modular robots. If anyone's ever seen that movie Big Hero 6, all these robots connect together, and they can, solve puzzles, move objects around, and just do a lot of really cool things. And we're connecting them to brain-computer interfaces. So this is my colleague, Ashley. She's wearing an EEG headset on top of her head, and we're mapping the brain signals from the EEG headset to specific actions that you could do with the robot. So we can make the robots expand and contract when they're in their pyramid configuration, and we can have them move around through mazes. So here are a few pieces of advice. I'm still not much older than many of you, and I might be the same age as many of you. But if you really love something and you're really interested in it, here's a few pieces of advice. First is age isn't really an excuse for everything. There's so much new technology coming out. I mean, every single day, there is a new paper that revolutionizes AI in a very small way. And that's why we've been able to make so many advancements so quickly. Everybody basically starts at a level playing field every single week, because there's something new that somebody who's maybe 30 didn't learn in university because it just came out the day before. So everybody's pretty much at the same level. Whether you're 15 years old or you're 30 years old, you're all learning at the same rate. Second is you can learn literally anything that you want. I was studying out of textbooks and YouTube videos how to build AI models because I wanted it to do my homework. And if any of my teachers are watching, I definitely didn't use it for your class. You can learn whatever you want. Everything you want to learn online is free. I mean, the universities publish their resources for free. There are YouTube videos of people just going through whatever you want to learn. So if you want to learn something, just look it up. And the last thing is fuck around and find out. This is the best piece of advice that I've ever received. And if you're not breaking, you're not really learning anything. It's about the building and the rebuilding where you actually learn and gain experience in building. If you're not failing, you're not trying. And a lot of the times, a buggy code or a broken circuit is going to teach you a lot more than a textbook. Because if you're just reading a textbook but don't apply it in real life, then you're not really getting better at anything. So do that. And that's really all I have to say. Thank you so much, Futureport Youth, for having me. This is an amazing event. And thank you.
Can I stop you for a second? Sure. Good. Could you still share the story, how you emailed one important guy to get a graphic card?
Yeah, sure. Okay, so the story is back when I was 12 years old, I really wanted to build a PC. And so I asked my parents, can I build this $2,000 gaming PC? And like most parents, they said no, definitely not. So what I did is I was 12 years old, and I was kind of ambitious and a little stupid too. So what I did is I wrote an email to the CEO of NVIDIA, and I was like this squeaking kid, and I said, if I make a video for you, could you sponsor the video and pay for all the PC parts? Within 2 hours, Jensen Huang responded with, sure, happy to help. So So over the next few months, I was talking to like people at NVIDIA about like, oh, which are the best PC parts to use for this specific kind of monitor, like for the games I wanted to play, and that's where I originally got like my original gaming PC. Before that, I had like a pretty cheap random PC, and I was still building my setup with that. But once I got that gaming PC, I could start playing games, and then eventually using like a strong enough computer, I was able to code all this AI stuff that I've been able to work. And I still use that computer like 6 years later. So, yeah.
Thank you. So, yeah, never think something is impossible. Just try, right? Thank you, Samay.